Welcome back to Mr. Vaughn's classroom, where math is made easy. Before we get started on today's lesson, I'd like to ask you to please hit the subscribe button, give this video a thumbs up, and engage with a comment below. Today we're looking at Unit 6, Introduction to Quadratic Functions, Lesson 13, Graphing the Standard Form, Part 2. The learning goal today says let's change some other parts of a quadratic expression and see how they affect the graph. We have two learning targets. At the end of the lesson, we'll come back and we'll review these and make sure that you understand everything you need to moving forward into the next lesson. Learning target number 1 says I can explain how the b in y equals ax squared plus bx plus c affects the graph of the equation. Learning target number 2 says I can match equations given in standard and factored form with their graph. Our first practice problem for lesson 13 says here are 4 graphs. Match each graph with the quadratic equation that it represents. So we can do this by looking for things that are different in the graph and then looking for things that are different in the equations. So the first thing I would want you to notice is that graph A opens upward, graph B opens upward, graph D opens upward, graph C is the only one that opens downward. In a previous lesson, we had said that if the A term was negative, that would cause it to open downward. And if we look at our choices here, the only equation that has a negative A term is going to be equation 2. So the negative A means that it opens down. So that tells me that graph C matches equation number 2. So that takes care of one of our choices. Now, we can look for something different in the other 3. If I look at graph A, it has shifted down and to the left from the origin. Graph B has also shifted down and left of the origin. Graph D, however, has shifted down and right from the origin. So now let's look at our B terms. We have a positive 1b, we have a negative 1b, and we have a plus 3b. So we have 2 positives and 1 negative. Well, the one that is different is graph D. It shifts down and right. So the negative B shifts down and right. So that means graph D must be equation 3. So now we have a positive 1 and we have a positive 3. If I look at graph A, it has shifted down and left so that I have an x-intercept at negative 1. Graph B has shifted down and left so that I now have an x-intercept at negative 3. So that tells me that plus B shifts down and left and x-intercept at negative 1. So graph A matches equation number 1. On equation 4, we have a plus 3. So this tells me shift down and left with an x-intercept at negative 3. So graph B must match up with equation number 4. Now we can take a quick look at this and understand why this is what happened. If I have equation 4, I had x squared plus 3x. Well, I can pull an x out of both of these terms, and in factored form, that would be x times x plus 3. So now you can see that if I'm looking for my x-intercepts or my zeros, then I'm going to have x equals 0, which puts it right here at the origin. And I'm going to have x plus 3 equals 0, which means x must be negative 3, which is my other intercept. That's why this downward left shift happens. If I look at equation 1, here we had x squared plus x. If I pull an x out of both of these and factor it, it becomes x times x plus 1. So now, if I let each of my factors be 0, I have x equals 0, which is here at the origin. And I have x plus 1 equals 0, which means x must be negative 1. And I see that at my other intercept. That's why the down and left shift happens. And the same thing for equation 3. If I have x squared minus x, and I factor out an x and make it x times x minus 1, then again I set x equal to 0, and there's my intercept at the origin. And then I set x minus 1 equal to 0, which means x must be positive 1. That's why it causes the down and right shift. If you have any questions about this practice problem, please leave a comment below and I'll get back to you with any help that I can offer. Practice problem number 2. Complete the table without graphing the equations. So in the middle column, they want the x-intercepts, and in the right column, they want the x-coordinate of the vertex. So in every one of these, we have ax squared plus bx. So what we can do is we can factor this and then set the factors equal to 0 to find the x-intercepts. So in the first one, I would factor out an x, and then it would be x times x plus 12. If I set x equal to 0, then my x-intercept is at 0, 0. If I set x plus 12 equal to 0, then the x must be negative 12, and so my intercept would be negative 12, 0. To find the x-coordinate of my vertex, I'm going to combine my x-intercepts and divide by 2. So this is 0 minus 12 divided by 2, which is negative 12 divided by 2, which is negative 6. So I have x-intercepts at 0 and negative 12, and I have an x-coordinate of the vertex at negative 6. So in this one, my A is positive, my B is positive, and we can see that my shift was down and to the left. Now let's look at the second one. We have x squared minus 3x. So I am going to factor out an x. So I would have x times x minus 3. If I set x equal to 0, then I have an intercept at 0, 0. And if I set x minus 3 equal to 0, then x must be 3. I have an intercept at 3, 0. So this is going to be 0 plus 3 divided by 2, which is 3 divided by 2, which is 1.5. So in this example, my A is positive, my B is negative, and now if the x-coordinate of my vertex is 1.5, then I have shifted to the right and down. Let's look at the third one. Now we have negative x squared plus 16x. So I'm going to factor out a negative x. And this becomes negative x times x minus 16. So if I let negative x equal 0, then I have an intercept at 0. If x minus 16 equals 0, then my x must be 16. To find the x-coordinate of my vertex, I have 0 plus 16 divided by 2, which is 16 divided by 2, which is 8. Now, if you think about what this looks like, the negative a tells me to flip it upside down so that it's opening downward. So if I have a downward parabola with intercepts at 0 and 16 and an x-coordinate of 8, that means my a being negative and my b being positive has resulted in a shift that is up and to the right with my parabola opening down. And our last one, we now have a negative x squared minus 24x. So I'm going to factor out that negative x, and I would have x plus 24. If I set negative x equal to 0, then x equals 0, and I have an x-intercept at the origin. And then if x plus 24 is set to 0, then x must be negative 24. So I have an x-intercept at negative 24, 0. My vertex, or the x-coordinate of my vertex, is going to be at 0 minus 24 divided by 2, which is negative 24 divided by 2, which is negative 12. So now that I have an a that's negative and a b that's also negative, this is going to be a parabola that opens down and has intercepts at 0 and negative 24 with an x-coordinate of the vertex at negative 12. So this has shifted up and to the left. So now we can see that the b term works with the a term to determine how it shifts. If they are both positive, then it shifts down and to the left. If the a is positive and the b is negative, it shifts down and to the right. And in both of those, because a is positive, the parabola opens upward. On the other hand, if a is negative, we now flip the parabola upside down and it opens downward. And if the a is negative and the b is positive, we then shift that parabola up and to the right. And if they're both negative, we shift it up and to the left. If you have any questions about how the a term and the b term interact with each other to determine how the parabola shifts, please leave a comment below and I'll get back to you with any help that I can offer. Practice problem number 3. Here is a graph that represents y equals x squared. You see that it is the generic parabola opening upward with its vertex at the origin. Describe what would happen to the graph if the original equation were changed to y equals x squared minus 6x. Predict the x and y intercepts of the graph and the quadrant where the vertex is located. So, the first thing I notice is that A is positive and B is negative. When I see this, I expect a shift down and to the right. So remember that we start in the upper right, and we call this quadrant 1. Then we go counterclockwise. So this is quadrant 2. The bottom left would be quadrant 3. And finally, the bottom right would be quadrant 4. So if we're going to shift down and right, it should be in quadrant 4. Now they want us to predict the x and y intercepts. Well, the y-intercept is very easy. I simply put 0 in for x because if I'm on the y-axis, then my x value is 0. So that means 0 squared minus 6 times 0 equals 0 minus 0, which is 0. So my y-intercept is going to be at the origin. To find my x-intercepts, I'm going to factor an x out of this, and it becomes x times x minus 6. If x equals 0, then I have an intercept at the origin. And if x minus 6 equals 0, then when I add 6 to both sides, x equals 6. So I expect this to shift down and to the right. The vertex should be in quadrant 4. My x-intercepts should be at the origin and at x equals 6. And my y-intercept should be at the origin. Number 2 wants me to sketch the graph of this equation on the same coordinate plane as the original one. So what I'm going to do is I'm going to put my intercepts at the origin and at 6. Halfway between 0 and 6, if I have 0 plus 6 divided by 2, that becomes 6 divided by 2, which is 3. So my x-coordinate should be 3. If I want my y-coordinate, then I just substitute that 3 in. So that's 3 squared minus 6 times 3, which is 9, minus 18, which equals negative 9. So my vertex is at 3, negative 9. I come right 3, down 9. I put my point, and I draw my parabola that connects them. and we got exactly what we expected. We got a shift down so that the vertex was in quadrant 4, so down and to the right. We see a y-intercept at the origin. We see x-intercepts at 0 and 6. And we see a vertex at 3, -9. If you have any questions about how to solve a problem like this, please leave a message below and I'll get back to you with any help that I can offer. Practice problem number 4. Select all equations whose graph opens upward. So we know that it opens upward if a term is positive. So that's what we're going to be looking for. On choice A, we see that A equals -1. Because it's negative, this is going to open downward, so A is not a correct choice. If we look at B, we see that our A term is -5 because the A is the number in front of x squared. So this is negative. We want it to open upward. This one's going to open downward. So B is not correct. Choice C. This is in factored form, so in order to find the A term, we're going to multiply 2x times 2x. That will equal 4x squared, which is positive, so C will open upward. Choice D. This is also written in factored form. So in order to find the A term, we need to multiply the x terms by each other. This is going to equal -x times x, which is going to be -x squared. Since that is negative, it's going to open downward, not upward. So D is incorrect. And finally, choice E, we see that the A term is 1. Because that is positive, E is also going to open upward. So the main thing to know on this one is that it opens upward if your A term is positive. If it's already written in standard form, you're just looking for the number in front of your x squared. If it's written in factored form, you need to multiply your x terms together to create your x squared term, and then see if the number in front of the x squared is positive or negative. If you have any questions about this practice problem, please leave a comment below, and I'll get back to you with any help that I can offer. Our last practice problem for this lesson says technology required, so we're going to use the Desmos graphing calculator. Write an equation for a function that can be represented by each given graph. Then use graphing technology to check each equation you wrote. So for graph number 1, first I notice that I have an x-intercept at -7. If I have an x-intercept at -7, then that means it must be x plus 7 for that factor, because -7 plus 7 will equal 0, which is what the y value is for an x-intercept. Then I notice I have an x-intercept at 0, which means I have a factor of just x, because if I set it equal to 0, then it equals 0 for y. So these are my two factors that give me these two x-intercepts. Now I can just simply write y equals x times x plus 7 in factored form, or I can go ahead and multiply them together. X times x is x squared, and x times 7 is 7x. So I have the factored form, and I have the standard form to represent the graph in graph 1. Graph 2. First, I see I have an x-intercept at -4. That means my factor must be x plus 4, because -4 plus 4 is 0. Then I notice I have an x-intercept at +4. And that means I would have a factor of x minus 4, because 4 minus 4 is 0. Now, I can have x plus 4 times x minus 4. That is my factored form. Or I can go ahead and multiply them together. X times x is x squared. X times -4 is -4x. 4 times x is +4x. And -4x plus 4x is 0. And then I have 4 times -4, which is -16, for my standard form. So now I have the factored form and the standard form for graph 2. And finally, graph 3, I see that I have an x-intercept at -9. That means my factor must be x plus 9, because -9 plus 9 is 0. And then I notice that I have an x-intercept at +3. That factor would have to be x minus 3, because 3 minus 3 equals 0. So now if I want the factored form, I can simply write x plus 9 times x minus 3. or I can go ahead and multiply them together. X times x is x squared. 9 times x is 9x. X times negative 3 is negative 3x. 9x minus 3x is 6x. And 9 times negative 3 is negative or minus 27. And this would be my standard form. Now, we can go ahead and use the Desmos calculator to check these. Our first one we said was x squared plus 7x. So x squared plus 7x this gives us a parabola that opens upward with x-intercepts at 0 and negative 7 and a vertex at negative 3.5, negative 12.25. If we look, that's exactly what we have here. So graph 1 and our equations are correct. The next one we said was x squared minus 16. So x squared minus 16. We have a graph opening upward with a vertex at negative 16 and x-intercepts at 4 and negative 4. And that's exactly what we see in graph 2. So we know that we're correct there. And graph 3, we had x squared plus 6x minus 27. So x squared plus 6x minus 27. What we see is an intercept at 3, negative 9, and a vertex at negative 3, negative 36. 3, negative 9, negative 3, 36. So we can see that in order to write the equations from the graphs, we can simply look at our x-intercepts, write the factor that would need to be there to cause each of those intercepts, and then we have our factored form, and if we multiply those factors together, we can get our standard form. If you have any questions about anything we went over in today's practice problems, please leave a comment and I'll get back to you with any help that I can offer. Now, before we finish this lesson, let's go back and review the learning targets and make sure you know everything you need to moving into the next lesson. Looking back at our learning targets for this lesson, learning target number 1 says I can explain how the b in y equals ax squared plus bx plus c affects the graph of the equation. So what you need to remember here is that the a and the b work together to either shift it down and left, down and right, up and left, or up and right, because you have 4 different possible combinations. Either A and B are both positive, A is positive and B is negative, A and B are both negative, or A is negative and B is positive. Learning target number 2 says I can match equations given in standard and factored form with their graph. So now you should be able to take the factors from factored form and use them to find your x-intercepts. You should be able to put 0 in for x and find your y-intercept. And you should be able to combine your x-intercepts, divide by 2 to find the x value of your vertex, and then substitute that x value into the equation to find the y value of your vertex. And then you should be able to match these points with the graphs. When you're looking at the standard form, you should understand that the c term is your y-intercept. You should understand that the a term, if it's positive, it means your parabola is opening upward. If the a term is negative, it means your parabola is opening downward. And you should know that your b term is working with your a term to either shift it up and left, up and right, down and left, or down and right, depending on the mixture of positive and negative a and b terms. If you have any questions about either of these learning targets, please leave a comment below and I'll get back to you with any help that I can offer. On the screen, you should see a video that YouTube believes will be helpful to you. If you found this video helpful, please hit the subscribe button, give this video a thumbs up, and I look forward to seeing you in the next lesson.